Hi, I'm Dirksha, the one in the red t-shirt, a member of the FRC Team 7539, Team Elevate, and this is my video submission for the WPI Design and Innovation Scholarship.
Team 7539 is one of the three FRC teams in India and it is its second year participating in the first robotics competition. I've had the immense pleasure and the privilege to be a part of this team since its conception.
During the off-season, with the help of our mentors, we held sessions thrice a week after school and taught the new team members essential skills like how to use CAD in Fusion 360, how to use Power Tools, introduction to Java programming for the robot, and Python for vision processing. After these introductory sessions, we started working, applying these skills that we learned to build our last year's robot all over again and build another kit of part chassis for the programming team to debug and test their code on. This was done by dividing the sub-teams further randomly and allocating work to each and every member. These team bonding activities served as learning moments for students as well as me to analyze problems, use our own instincts when faced with a problem during build or programming, get familiarized with FRC and all its power tools and electronics, and most important of all, get familiarized with each other. By developing Team 7539's problem solving and technical skills through hands on work, we prepared ourselves to spend long hours in an environment where knowledge and teamwork meet technology, which enables innovation. Among the many changes and improvements made this season to our team's organization and communication methods, the student leaders thought it would be helpful to implement Autodesk Fusion 360 in our standard workflow rather than SolidWorks, which we used last year. We chose Fusion because it enabled and encouraged collaborative designing and allowed all the members of all subteams to access the design from Autodesk Cloud Services. During the build season, ideas about the robot and mechanisms were discussed after school and the CAD designs were prepared at home and prototyping began the next day. The programming team worked on their vision and autonomous code on the KOP chassis. The construction team was split further, each team working on a specific mechanism. This new workflow allowed members with less experience to contribute and ideate alongside the veterans and enabled the effective communication between the construction, programming, and electrical team to deploy the electronic and pneumatic system in the program ready to install and deploy on the mechanical completion. In first Infinite Recharge, Team 7539 decided that the robot should cross the initiation line in the auto period, shoot parcels in the upper port, and hang. This year I'm leading the constructions and electrical team and I'm part of the drive team as well. In the ongoing build season, I alongside a couple of other members are focusing on developing the hanging mechanism. We started off by researching and looking at hanging mechanisms of robots of previous FRC seasons, like the Stronghold. This was followed by a brainstorming and discussion sessions where we ideated and came up with possible CAD drawings. The hanging mechanism consisted of two aluminium box pipes which were pulled with the help of two Falcon 500 motors through chain and sprockets to a height of 6 feet 7 inches from the ground, which was the max height of the shield generator when tilted. We used Falcon 500 motors because it gave us almost 3 times the stall torque of a normal CM motor and was faster than using a worm gearbox. The main problem we identified was balancing. In theory, all hanging robots can strategically align their robots and hang simultaneously or one after the other in order to balance. But in practicality, due to the time crunch or improper hanging and or sliding due to gravity, the clockwise and anti-clockwise movements don't equal and so the rung is in balance. So in order to balance the shield generator, we designed a mechanism that we call the Skywalker. Essentially, it's a hook with two wheels. We used a PG motor to power two 4-inch stealth wheels with a separation of slightly smaller than the width of the rung, 1/4 inch. The wheels act as a hook that are connected to the aluminium box pipes. After it hooks on the rung, by powering the wheels, the robot can be moved left and right in order to equalize the moments and hence balance the rung. Additionally, we had an 8-wheel West Coast drive chassis with a drop center that allowed turning. All 8 wheels were 6-inch traction wheels that helped us hold ground during defense and helped us climb over the extrusions of the playfield. But due to the placements of our electronic and pneumatic systems and a shooting mechanism, we could not power all wheels. Furthermore, the small drop center made point turns very jerky and dangerous as the robot could fall over. So, to solve this problem, we kept 6 wheels as traction wheels and added 2 Omni wheels at the front. We powered the Omni wheels as it was difficult to climb over the extrusions without them being powered. The 2 Omni wheels gave us better turning and stability. To me, FRC is more than a competition. It has taught me the importance of collaboration, patience, critical thinking, in addition to essential technical skills while bringing all of us closer. For the 2 years I've been a part of it, I've loved every bit of it.